All right, in math, what's a matrix? Some of you asked about what matrices were after our ACT that we took in April, and so here with our last week of school, we have an introduction to those. A matrix is an organized list of numbers. The rows are horizontal, so this is row 1, row 2, row 3, and the columns are vertical, so this is column 1, column 2. Every element, you call a number in a matrix an element, has a unique location. Row first, column second. So I could ask you to tell me the number that's in row 1, column 2. So row 1, column 2. Row 1 is at the top, column 2 is at the right. This 5 right here is the element that's in row 1, column 2. And so matrices are useful then in computer programming because they can store numbers and then easily pull out a number to be used in a formula because of its location. All right, you can also hold information in a matrix if you know its dimensions. So we have to get used to talking about counting the number of rows and counting the number of columns to say how big a matrix is. So the matrix that we're looking at here has 1, 2, 3 rows and 1, 2 columns. So this would be known as a 3 by 2 matrix. Okay, let's carry on. So these matrices up here at the top, the dimensions of each one. Remember, rows go across, columns go up and down. So this one has 2 rows by 1, 2, 3, 4 columns. So that's a 2 by 4 matrix. This matrix has 1, 2, 3 rows, all in 1 column. So this is a 3 by 1 matrix. And then 1, 2, 3. So this one has 3 rows and 1, 2 columns vertical like on a porch. So 3 by 2. All right, dimensions are important to us when we want to try to add and subtract matrices. You have to understand dimensions for me to tell you that matrices must have the same dimensions if you want to add or subtract them. The reason they need to have the same dimensions is that every element has to have a partner in the second matrix in the exact same location. So if I look at the 3 adding and subtracting problems beneath here, this first one, not possible because there's 4 elements in the first matrix and there's 2 elements in the second matrix, and so not everything would have a partner. So this is not possible. That's a 2 by 2 matrix and a 2 by 1 matrix, and they cannot be added or, in this case, subtracted. However, beside it, there's a, let's see, 1, 2, 3, so a 3 by 2 matrix next to another 1, 2, 3 by 2 matrix. They have the exact same dimensions, so I am able to add them. To add them, it's what you would guess you would do. You would add corresponding elements. So row 1, column 1 in both matrices go together. So negative 2 plus 1 would be negative 1. And then 1 plus negative 4 would be negative 3. And then 0 plus negative 2 would stay negative 2. And then 3 plus 9 will become 12. And 7 plus 1 would become 8. And I need one more color. I guess I'll just go back to yellow. And 6 plus 5 would make 11. Okay? Corresponding elements. Row 1, column 1 in both matrices gets added together. Row 2, column 2 in both matrices get added together, etc., etc. All right, third example. These are one row, 3 columns. Both are the same, so these are able to be subtracted. Now, when we've been subtracting polynomials all trimester long, and then rational expressions, we've been talking about distributing that negative. And so we do that with matrices as well. Negative, negative 2, that's going to become positive 2. The positive 8 will become negative 8. The negative 5 will become positive 5. And then we add the matrices together. So the 3 will add with the 2, and we'll get a 5. The 15 will add with the negative 8, and we'll get a 7. The negative 2 will add with the 5, and we'll get a 3. So make sure you distribute that negative, as we have done in polynomial chapter and in our rational expressions chapter that we just finished. Okay, there's one more type of operation to deal with today, and that is scalar multiplication. Scalar multiplication is when you need to scale the matrix, multiply the matrix by a value. So we have a 4 times this matrix, and so what that means I need to do is distribute that matrix, that 4, to every element in the matrix. So negative 4, positive 8, negative 16 becomes the new row 1. 4 times 0 would still be 0. 4 times 6 would be 24. 4 times negative 2 would be negative 8. 4 times 0.5 would be 2. 4 times negative 2 would be negative 8. 4 times 3 would be 12. Easy peasy, lemon squeezy. All done. All right. The final thing we can do, if we understand matrices and their dimensions and how we organize their elements, we can use them to evaluate or solve little equations. So one final example down here, we have a 2-row, 2-column matrix added to a 2-row, 2-column matrix, and so the answer equals a 2-row, 2-column matrix. If we know that each corresponding element creates that number in the answer, then we can make some small little equations here. We can say that x plus 5 equals 10, and then we can do some quick solving or mental math and find out by subtracting 5 that x needs to equal 5. Let's see, if we can have 3 plus negative z, and the answer needs to come out to 18. So 3 minus z equals 18. Okay, some quick math here. I need to subtract 3 and divide by negative 1. So 15 equals negative z, but if I divide by negative 1, then z equals negative 15. Let's see, negative 6 plus 0 equals w. That doesn't sound difficult. Negative 6 plus 0 equals w, so hey, w must equal negative 6. Mental math there. Lastly, 3 plus 7 equals y plus 6. So 3 plus 7 equals y plus 6. So 10 equals y plus 6. So if we subtract the 6, 4. Y equals 4. Okay, so give that a try. See if you have questions.